Welcome to our science video. Today, we're diving into the fascinating world of separating mixtures. Mixtures are everywhere around us, but what happens when we need to separate their components? Let's explore various methods to achieve this. Our first method is decanting. Imagine you have a mixture of sand and water. The sand settles at the bottom while the water remains on top. By carefully pouring off the water without disturbing the sand, we can separate the two. Decanting works based on the principle of density. The denser component settles at the bottom while the lighter one remains on top. Next up, filtration. Let's say we have a mixture of sand and water again, but this time, the sand particles are too fine to settle. We pour the mixture through a filter paper or a sieve. As the water passes through, the sand particles are caught by the filter, leaving behind pure water. Filtration separates mixtures based on particle size, with larger particles being trapped by the filter. Now, let's explore evaporation. Consider a solution of salt dissolved in water. By heating the solution, the water evaporates, leaving behind the salt. During evaporation, the liquid component turns into vapor and escapes, while the solid component remains behind. This method is useful for separating dissolved solids from liquids. Moving on to magnetic separation. Suppose we have a mixture of iron filings and sulfur powder. By using a magnet, we can easily separate the iron filings from the sulfur. Since iron is magnetic and sulfur is not, the magnet attracts the iron filings, allowing us to separate them from the mixture. Distillation is another powerful method for separating liquid mixtures based on differences in boiling points. Imagine we have a mixture of alcohol and water, like in alcoholic beverages. Distillation allows us to separate these components. In a simple distillation setup, the mixture is heated in a flask. As the temperature rises, the component with the lower boiling point vaporizes first, rising into the condenser. In the condenser, the vapor cools and condenses back into liquid form. Meanwhile, the component with the higher boiling point remains in the flask, still in liquid form. This process of distillation effectively separates the components based on their boiling points. Chromatography is another useful method of separating mixtures. Paper chromatography is used to separate different pigments or dyes in a mixture. Some pigments will travel faster up the paper because they have a higher affinity for the solvent, while others will move more slowly because they have a stronger affinity for the paper. Thank you for joining us on this exploration of mixture separation methods. We hope you found it both informative and enjoyable. Stay curious and keep experimenting. Until next time, goodbye.